Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, we have some information about this diagram, and then options with different nature. So this means that we'll have to test all the options one after the other. So first, let's fill out what we have. We have BAC as 50 degrees, CBO as 50 degrees, and half BOC is 50, so BOC itself will be 100. Okay, so we also have that AB is equal to BC. Alright, so for the first one, we have, let's see if O is circumcenter of ABC. For that to happen, then BO should be equal to OC as radius. And also the angle at the center, O, should be twice the angle at A. So that part is correct. So now, to check whether BOC is isosceles, we just fill out the remaining angle. Sum of angle in the triangle will give 30. So we see that this is not isosceles. So this is not possible. For ABC, I'll check whether it's equal to 60. We need to find this angle out. Now we observe that ABC is isosceles with base angles A and C. So angle at C altogether should also be 50. And here we are left with 20. And on the other hand, we know the two base angles, so we can actually get the angle at B to be 80, which is different from 60, so B is off. And from that, that means this part here should be 30. Next, BO perpendicular to AC, so that means we just extend BO. Let's say it meets this at D. I want to check the angle at D to see if it's going to be 90 degrees. So if you look at triangle ABD, we see that we can figure out the final angle. So angle at the external will be 50 plus 30, which is 80 here. So this is actually 100, and that's different from right angle, so this is also false. Now area of ABC is thrice that of BOC. Okay, so for this one, we see that if we consider the area of BOC to be this color here, then 3 times BOC should give the full area. So first we're going to show that the area of ABD is also the same, and that will mean that the remaining part here should be the same as well. So we'll just quickly observe that triangle BOC and triangle ABD are similar. So angle at B is 50, so that will be corresponding to A. Angle at O is 100, so that's D. Angle at C is 30, so that's B. And in fact, they are actually congruent because the side length BC is equal to AB, so they are congruent. Alright, so now next we see that for these two areas to be equal, triangle BOC and triangle DOC, they both share vertex C, so the height from C is going to be equal for both of the triangles. And since the areas are equal, half base times height means that the base lengths will also have to be equal. As we need BO equal to DO. Okay, so let's call this length, say X. So here we'll have X. Let me use a different color. So let's say we have X here and X here. Okay, then from that we see that what we have now is BD itself with 2x, and BD from this length, meaning we can get the corresponding length in the other congruent triangle, which is OC. So OC will have to be 2x. And next we'll see that this angle here, that's angle DOC, is also 80. So that means ODC is isosceles. So we have that OC be equal to DC, and that will be 2x. Okay, so this here is 2x as well. So what we get is this diagram involving silent x. So we have this isosceles triangle where this is C, this is D, this is O. So this here is x, 2x, 2x, 80, 20, 80. So we just use sine rule now to check that this is an actual triangle. So we have a sine 80 over the opposite, which is 2x, should be equal to sine 20 over x. And here we see that x can cancel out, so this will just give sine 80 is 2 sine 20. Now sine 80 is the same as cos 10, and sine 20 is the same as 2 sine 10 cos 10. That's using the double angle formula. So this means that by cancelling out cos 10 from both sides, we have 4 sine 10 is equal to 1, and that means that sine 10 will have to be equal to 1 over 4. And it's not too difficult to check that this is not the case. So what we just do, compute compare this with sine 30, so which is twice the angle of this. So we can first of all get cos 10 to be the square root of 1 minus 1 over 4 all squared. So we simplify this, we just get root 15 over 4. And then sine 20, which is 2 sine 10 cos 10 by double angle formula, we just give root 15 over 8. And then cos 20, which will be we can use 1 minus 2 sine squared 10. Okay, so if we use this, we get 1 minus 1 over 2 over 16, so we get 7 over 8. Okay, so now that we have this, we can talk about our familiar sine 30, which can be written as sine 10 plus 20. So this is sine 10 cos 20 plus cos 10 sine 20. So we just multiply them like this and add it up. So we have 1 over 4 times 7 over 8 plus root 15 over 4 times root 15 over 8. This is 7 plus 15 over 32. That's 22 over 32, which is clearly not equal to the expected answer half. So this means finally we can be sure that this is not correct. And then we're left with option E. So just confirm whether this is correct. We have AC equal to BO plus OC. BO is x, OC is 2x. So for that to be equal to AC, we need AD to be x. So just confirm. Come back to this congruency. We see that BO corresponds with AD. So indeed BO is equal to AD. So this is also x, and then option E will be the correct option. Alright, so I hope you enjoyed. I'll see you on another one.